Welcome back. We will work today on chapter 6, section 6.4, dividing polynomials, long division and syntactic division. The first objective is to divide a polynomial by a monomial, and we divide a polynomial by a monomial by dividing each term in the polynomial by the monomial, and that's going to be something like that. If you have two polynomials, a plus b divided by c, then this is the same as the polynomial a divided by c plus the polynomial b divided by c. Let's apply and see how it works on an example. And we have here this example: negative 12a cubed plus 36a minus 15, the whole expression divided by 3a. This is going to be equal to negative 12a cubed, so we separate each term, each monomial, and divide by 3a, plus 36a divided by 3a minus 15 divided by 3a. And then we can simplify. The first one you can simplify, you can divide 12 by 3 is 4, and a cubed simplified divided by a is a squared. Okay, the first one is negative 4a squared. The next term here we have is plus 36 divided by 3, 12, and a we can simplify with a is 1. Minus, and 15 divided by 3, 5 over 8. This is the result. This is how you divide a polynomial by a monomial. Next example, let's see this one now. And we have 10t to the fourth minus 35t cubed plus 5t squared, the whole expression divided by 5t squared. But this is equal. So divide each one now by the monomial, each term of the polynomial. So 10t to the fourth divided by 4t squared minus 35t cubed over 5t squared and plus 5t squared over 5t squared. Simplifying, then we're gonna find 10 divided by 5, 2, and you can simplify t fourth. With this t squared, it's gonna be t squared. Let me write down here so I don't forget. 5t squared minus, next one, 35 divided by 5, 7. T cubed simplified with t squared is just t. So writing down here on the bottom, 7t. Plus, and of course 5t squared divided by 5t squared is 1. And this is the solution. Next, objective number 2, dividing a polynomial. And when we divide a polynomial by a polynomial, another polynomial, other than a monomial, we can use a long division technique that is similar to the process known as long division in dividing two numbers. Let's review how it works by dividing two numbers. And we have here 7,256 divided by 43. This is the division that we are working on. And the first thing you have to do is divide 72 by 43. It's going to be 1. 1 times 43. We write down here 43. And then subtract, right? 72 minus 43, 29. Then drop another one, another unit, the next number here. Now the 29 is going to become 295. 295 divided by 43 is going to be 6. 6 multiplied by 43, 258, 258. Then subtract 295 minus 258. Then you have 37 as a result. Drop the next number, 6. 376 divided by 43 is going to be 8. Right? 8 multiplied by 43, 344. The remainder is 32. And this is the remainder. The result then is going to be 168 plus the remainder divided by 43. And this is how we do the division, the long division with numbers. Now we're going to see how to do the long division applying the polynomials. As you can see from the previous example, there is a pattern in the long division technique. You divide, multiply, subtract, then bring down, and afterwards you repeat these steps until you can't bring down or divide anything any longer. We will incorporate the same repeated technique, the same pattern, the same step-by-step with dividing polynomials. Let's work this example here. We will divide 28x squared minus 23x minus 15 by the polynomial 7x plus 3. And the first step, the first thing we have to do is divide 28x squared by 7x. 28 divided by 7, 4. X squared divided by x, x. Right? Now I multiply 4x by the whole polynomial, the whole thing. So 4x times 7x is 28x squared. And 4x times 3, 12x. Okay? You're going to subtract this, the original polynomial from this one that you found as a result, 28x squared minus 28, 0. Negative 23x minus 12x, negative 35x. And you can drop here the next one, minus 15. Okay, next step, divide negative 35x by 7x. Negative 35 divided by 7, negative 5. X divided by x, 1. That's it. Now multiply the whole thing, this one thing by the whole divisor. Negative 5 times 7x, negative 35x, and negative 5 times 3, negative 15. Subtract, and you're going to have 0 and 0. Right? That means there's no remainder. No remainder. And your answer, our answer, the answer that we are looking for is going to be 4x minus 5. Is the result of 28x squared minus 23x minus 15 divided by 7x plus 3. Let's work this next example, and we are dividing now 4x squared minus 6x plus 8 by 2x plus 7. And the first thing we have to do is to divide 4x squared by 2x. 4 divided by 2, 2. X squared divided by x, x. Now multiply 2x by the whole divisor, by 2x plus 7. 2x times 2x, 4x squared. And 2x times 7 is 14x. Subtract, then you're going to have here 4x squared minus 4x squared, 0, and negative 6x minus negative, if positive is negative, right? Negative 6x minus 14x is minus 20x. Drop the next one, that's 8, and let's divide negative 20x by 2x. Is going to be negative 20 divided by 2, negative 10, x divided by x, 1. Now get this result here and multiply by the whole thing, 2x plus 7. Negative 10 times 2x, negative 20x, and negative 10 times positive 7 is negative 70. We are going to subtract negative 20x minus negative 20x, that's going to be positive, so 0. And positive 8 minus negative 70, negative with negative positive, 70 plus 8, 78. And this is going to be the remainder. That means the result, the final answer, is going to be 2x minus 10, this, plus the remainder, 78, divided by 2x plus 7. And this is our final result. Moving on, let's have a look at another example. And now we have here, this is in the shape or in the form of a fraction, c squared plus 3c minus 2 divided by or over c plus 1. And we write down in the long division form, like this. So the first step here is going to be to divide c squared by c. Then we have, as a result, c. Then multiply by the whole thing. C squared plus c. Subtract. And c squared minus c squared, 0. Positive 3c minus c, positive 2c, right? Drop negative 2 minus 2, and then divide 2c by c, plus 2. Multiply positive 2 by the whole divisor, 2 times c, 2c, 2 times 1, positive 2, right? Subtract, and you will have 0, and move this up a little bit, 0, negative 2 minus positive 2, this negative here with positive becomes a negative, right? Negative 2 minus 2, negative 4. This is the remainder. So then we can write down the answer, the solution, as c plus 2 minus 4 over c plus 1. Okay, and now that we've seen this example, I think we can work out another example just to be sure that we understood how to do this long division operation. Now the division is expressed with this division sign here, y squared minus 5y plus 6 divided by y minus 2. So write down in the long division form, start by dividing y squared by y, then you have y, and then multiplying y by the whole thing, y minus 2 is going to be y squared minus 2 multiplied by y minus 2y. Subtract, then you have 0, negative 5y minus negative 2, this becomes a positive, right? So negative 5y plus 2, negative 3y. And drop 6. Now you're going to divide negative 3y by y. This will result negative 3. Multiply negative 3 by the whole thing. Negative 3 multiplied by y, negative 3y. Negative 3 multiplied by negative 2 is positive 6, right? If you subtract, then you have 0, no remainder. It's always good to check your solution. At the end, it's interesting to multiply. You can try your solution, check your solution by multiplying the result y minus 3, the result y minus 3 by the multiplied by the divisor y minus 2, and then you're gonna find, after you perform the distribution here and all the operations that you need to simplify, combine like terms and everything, you have to find out the original expression y squared minus 5y plus 6, just to check and confirm you got the right answer. Let's work now on objective 3, using syntactic division to divide a polynomial by a binomial. And to find the quotient and remainder when a polynomial of degree 1 or higher is divided by x minus c, a shortened version of long division called syntactic division may be used. What is important to understand here is that the syntactic division is only applicable if you are dividing a polynomial by this binomial of this form, x minus c. It can be like divided by x minus 2, it can be divided by x plus 5, then c is going to be negative 5, but always only is applicable if the divisor is something of this shape, x minus c. And let's go straight to some explanations here. The syntactic division is kind of a simplification, is a step-by-step simplifying method that you can apply. And let's apply to an example, because I think if you want to understand, you can go through the slides here, but actually what's important is to apply and to work a division using the process. Now let's use the syntactic division here to divide 3x cubed minus 2x squared plus 5x plus 4 by x minus 2. See, this is x minus c. That means c equals 2. Then here you're gonna write down c. This is c, right? And here you're gonna write down the sequence of coefficients and in the polynomial that's being divided. And we have here 3, -2, 5 and 4. 3, -2, 5 and 4. Because you have all the sequence of exponents here: exponent 3, exponent 2, exponent 1 and exponent 0. Okay, so that's how we organize the synthetic division method. We write like this. Then the first step of the synthetic division method is to drop the first one. Drop the first one here, the first coefficient, the first number. You're going to multiply by c, multiply by 2, 3 times 2, 6, and you're going to write down here under the next coefficient. So the next step, you're going to perform the operation. -2 plus 6. -2 plus 6 is going to be 4, right? Now again, you get this one, you multiply by c. 4 multiplied by c, 4 times 2, 8. Then you write down here on the next, under the next exponent. And you perform 5 plus 8, 13. Again, 13 times 2. 13 times 2, 26. And you write down here under the last exponent, the last coefficient, the last coefficient 4. And you perform 4 plus 26, 30. This last one here is going to be the remainder. This is the remainder. And the solution is going to be 3x squared plus 4, here 3x squared plus 4x plus 13 plus the remainder 30 divided by x minus 2. This is the result of the division that we found by using the method of the synthetic division. It's a method, a step-by-step, that you can use to find quickly, much quicker than a long division, but only applicable if, again, this is very important, only applicable if you're dividing a polynomial by a binomial in this form here, x minus c. Okay, now let's move to the next objective. It's using the remainder theorem to evaluate polynomials. And actually the remainder theorem is quite useful, because you can find the remainder of a division pretty quickly. And also the same thing, this is applicable if the division is by a binomial with this form, this shape, x minus c. To calculate the remainder is going to be actually equal to the polynomial that you are dividing when you plug in the number c. And let's understand here with an example. This is the synthetic division of this polynomial here, 4x to the 6th minus 25x to the 3rd plus 35x to the 4th plus 17x to the 2nd to the squares. And this is the synthetic division. You're gonna write down 4 here, 25, right, 35 here, and we don't have actually gonna be 0 times x cubed, right? So 0 and 17. Here 0 plus 0 times x, here plus 0. You have to complete all the coefficients like this. And so you apply the synthetic division as we have seen. The multiplication, here you find the result, you write down under the second, the next coefficient, and add together and keep doing this, keep doing this, keep doing, you're gonna find the remainder. This is the remainder. Now let's try the remainder theorem. Let's calculate the remainder by plugging in C, which is 4, right? 4, and calculating the result. And then this is going to be equal to 4 times 4 to the 6th minus 25 times 4 cubed plus 35 times 4 to the 4th plus, and let me get some space here. Let me move this and get some space. Plus 17 times 4 squared. Type this operation here in your calculator. It's kind of a long operation, but actually when you finish and you get the results, you're gonna realize that P of 4, if you plug in x equals 4 here and this polynomial, you're gonna have as a result 16, which is the same value as the remainder, equal to the remainder. Now we finish section 6.4. Thank you for watching. See you next time.